Okay, the purpose of this video is to describe a student activity that you might use in centers or stations to help students develop conceptual understanding and procedural fluency for using pictures to model fractions. So what's in this kit? It's a pretty straightforward kit. It has one of these double 10-sided die, one within the other, set of instructions, and several templates. Now these templates I can go over in detail later with you if you like, but the templates that you give to students can be as complex or as simple as you want. Really what you want to establish with students is how to use templates to start to build meaning. So I'm going to follow the instructions, and notice how the instructions are very similar to the instructions we had for building fraction, ruling fractions models. So it says first, students work alone. Now you can have students work alone, and then when they're done building they can explain their build to their partners. So you could have two partners working side by side, working alone, but then they are required to explain to each other. That's a really good way to develop their explanations. First I'm going to roll the die, and this one comes out to be a 6 over a 2. And so the first thing it says is to write the fraction to be built. And so I'm going to say fraction to build, or actually what I should say is model, is 6 over 2, or 6 halves. And notice how there's a 6 here on the outer and 2 on the inner. And so now I'm done with that, and now I have to model this fraction. And so remember that in the instructions we are reminded to define a whole, define a unit fraction, and then use the unit fraction to build the fraction we rolled. So what does that look like? So out of all these templates that I could choose, and any of them will work, I'm going to choose this one because for me it's the most versatile. So the first step, remember, is to establish the whole. So I'm going to say that for me, let's see, this will be equal to 1 whole. Okay, I've established the whole by defining the whole. Now if I want to divide that in half, then it's kind of simple. Just draw a line down the middle. They could do it horizontally as well. And I'll say that this now, this drawing, is equal to 1/2. And that's because 2 equal pieces make a whole. And on your drawing you could even say here's 1 and here's 2. 2 equal sized pieces make a whole. Okay, now that I've followed my instructions and I have defined the whole and defined the unit fraction, let's see, what's my next step? Use the unit fraction to define the fraction you rolled. So I rolled 6 halves. So for me to define 6 halves, then I think what I'll do is, let's see, here's 1/2. Here's another 1/2. Here's another 1/2. And we have to do this 6 times. That's 1, 2, 3, 4, 5. I need one more. So there's another 1/2. And notice that each of these halves is the same size as this half right here. And so now this is 1/2 plus 1/2 plus 1/2. You get the idea. That's equal to 6/2. Now, you might think there's a lot of activities we could do to get, equivalent fractions out of this and so forth, and that we will do those activities. But right now, I want students to understand how to build a fraction from a unit fraction that is defined in relationship to the whole. Remember, that's our whole goal here, and you'll see how important that becomes. Okay, the last step is to write a justification sentence to explain your reasoning for why your picture matches the fraction you rolled. And so my justification sentence might be something like this. 6 boxes is equal to 6/2 if each box has a value of 1/2. Now, this explanation portion is probably going to be the hardest thing for most students. So let's go over what we've done. In fact, it will be the most difficult thing for many students. So what have we done? First of all, we've built on the instruction that you've given to students in class, direct instruction. We've built on the practice that they've had building models with their concrete manipulatives. In this case, we used Cuisenaire rods. And now we've extended that to include pictorial representations where they're not actually using concrete manipulatives, but they are using pictures to represent the mathematical ideas. But these pictures, don't forget, we're using the academic language that's the same. And so when you're talking about English learners, all mathematical learners for that matter, keeping the consistency of the ideas in English the same helps a lot. We've gone from a concrete representation to a pictorial representation where we've done the same steps. Established a whole, understanding that a fractional portion can only be defined in relationship to a whole, and then using that fractional portion, the unit fraction, to build some arbitrary fraction. This activity, the student activity, is designed to give students practice doing those things. They need practice not only to make pictures, but to decide how to make those pictures, and then to explain their pictures to their partner or to somebody else. So this whole activity is designed to develop not only the academic language of mathematics, but the conceptual understanding of mathematics as well. And students, English learning students, non-English learning students, all students of mathematics need to develop that.